Hello friends, I am Shabi. Today we are discussing about the topic of laws of thermodynamics. What are the laws of thermodynamics and it is simply defined. First one is the zeroth law of thermodynamics. Before we go into the laws of thermodynamics or zeroth law of thermodynamics, first we should have the knowledge about what is thermal equilibrium condition. Thermal equilibrium. Thermal equilibrium. What is thermal equilibrium? Thermal equilibrium is a condition of a system when the temperature of the system and surrounding are same. Then there is another word, thermodynamic equilibrium. What is thermodynamic equilibrium? Thermodynamic equilibrium is nothing but simple. It is when thermal equilibrium and mechanical equilibrium and also chemical equilibrium satisfies for a system, then that system is called as a thermodynamic equilibrium condition. Then what is mechanical equilibrium and chemical equilibrium? Mechanical equilibrium means that there is no any unbalanced forces in that system. Then next one is chemical equilibrium. That means chemical equilibrium means that there is no any chemical reactions remains in that system. Okay, that is the thermal equilibrium and thermodynamic equilibrium conditions. Then we come to our laws of thermodynamics. First one is zeroth law of thermodynamics. Just watch what is the zeroth law of thermodynamics. Okay. Thermal well, there is three systems, A, B and C. If the system A and C are in thermal equilibrium, then the system B and C are also in thermal equilibrium separately. That is, A and C are in thermal equilibrium and B and C are in thermal equilibrium separately. Then the A and B are in thermal equilibrium. That is zeroth law of thermodynamics. Here is the A and B are in thermal equilibrium when A and C are in thermal equilibrium and B and C also are in thermal equilibrium. Then A and B are in thermal equilibrium condition. It is the zeroth law of thermodynamics. The temperature, you know about the temperature. What is the temperature? Temperature is the degree of hotness or coldness. The temperature is measured according to this law, zeroth law of thermodynamics. How we measure the temperature? Yes, we know with using thermometers. Thermometers are used for temperature measurements. When the temperature is higher value of temperature, such as boilers or such industrial machines, that time what we use for the temperature measurement? We use pyrometers. Pyrometers are used. The temperature measured in which unit? We know different scales of temperature. What are that? Degree Celsius, right? Celsius scale. Okay. Then second one is degree Fahrenheit. Right? This Fahrenheit scale. Then one important one is Kelvin. Kelvin scale. Kelvin. Okay. This is simply general introduction or simply about the zeroth law of thermodynamics. Okay. Then we can go to the first law of thermodynamics. Okay. The first law of thermodynamics is based on law of conservation of energy. What is law of conservation of energy? The energy neither can be created nor destroyed. We know about the law of energy, conservation of energy. It is law of conservation of energy. From that concept of conservation of energy, first law of thermodynamics says that if a closed cyclic system is we give a input heat to the system, the given input heat all are transferred into the work. The first law says that the when we give a heat or input to the system, then the total amount of heat is transferred into the work. That is when here is a system. Okay, for this system we are giving a Q1 temperature and a W1 is generated here. Then also we get output temperature or output heat Q2, output heat Q2. Then there is we can get a W2, that means output one. Okay. Then here is a internal energy delta du. Okay, internal energy. Here is Q1 plus W1 equals Q2 plus W2. From this, if this is this round, say this is a system. Then we get we are giving heat and getting output of work output. Then the equation is right. Then if Q1 I get this Q2 here, then Q1 minus Q2 equal to, there is a W2, this W1 goes to here, W1 minus W1. Then if Q1 plus W1 equals, there is a du, okay. Then du plus Q2 plus W2. Okay, Q2 plus W2. Then what is this when we Q1 minus Q2 equal to, what is that? We know du delta u change in du equal to du plus, okay, there is W1 and W2 there. W2 minus W1. Then subtracting the next step, we Q1 minus Q2 is actually total heat generated, okay, that is Q. So Q equal to du plus W. What is W? W is the total work done in the system. Okay, that means this is the equation for, or this is the first law of what says. Okay, this is also called Joule's law. This equation is also called the Joule's law. This is the basic concept of first law. അതായത് നമ്മളൊരു സിസ്റ്റത്തിനകത്തേക്ക് ഒരു ഹീറ്റ് ഇൻപുട്ട് കൊടുത്തിട്ട്, അല്ലെങ്കിൽ സിസ്റ്റത്തിലേക്ക് നമ്മളൊരു ഇൻപുട്ട് കൊടുക്കുമ്പോൾ ആ ഇൻപുട്ട് കിട്ടിയത് മുഴുവൻ എന്തായിട്ടുണ്ട്, വർക്കായിട്ട് ഔട്ട്പുട്ടായിട്ട് നമുക്ക് കിട്ടിയിട്ടുണ്ട്. ദാറ്റ്സ് സിംപ്ലി ദ ഫസ്റ്റ് ലോ ഓഫ് thermodynamics. Okay, clear? Then next we are going to discuss about second law of thermodynamics. What is second law of thermodynamics? Second law is defined by two statements. What are that? First one is Kelvin Planck's statement. Second one is Clausius statement. Kelvin Planck statement and Clausius statement. What are that? Check that. First one is Kelvin Planck statement. Kelvin Planck statement says that it is impossible to construct an engine. It is impossible to construct an engine which is sole purpose is to give output and give heat output to us. That is the total we given the heat totally converted to work. Okay, that is it is impossible to construct an engine which is sole purpose is to convert heat energy to work. Okay, അതായത് നമുക്കൊരു സിസ്റ്റം എന്ന് പറയുന്നത് ഒരു സിസ്റ്റത്തെ ഒരിക്കലും എന്ത് ചെയ്യാൻ പറ്റില്ല, ഒരു നമ്മൾ കൊടുക്കുന്ന ഫുള്ള് എമൗണ്ട് ഓഫ് ഹീറ്റും വർക്കായിട്ട് കൺവേർട്ട് ചെയ്യാൻ പറ്റില്ല. ഓക്കെ, ദാറ്റ് ഈസ് Kelvin blank statement says. Okay, the second one is Clausius statement. Clausius statement is simply that it states that when we are it is also it is impossible to for a cyclic process. The Kelvin blank statement is also for a cyclic process. We know about what is cyclic process. For a cyclic process, it is impossible to Clausius statement ആണ് പറയുന്നത്. For a cyclic process, it is impossible to transfer heat from lower temperature to higher temperature. Lower temperature ന്ന് heat ഒരിക്കലും എന്ത് ചെയ്യാൻ പറ്റില്ല, higher temperature നമുക്ക് ട്രാൻസ്ഫർ ചെയ്യാൻ പറ്റില്ല വിത്തൗട്ട് എയ്ഡ് ഓഫ് ആൻ എക്സ്റ്റേണൽ ഏജൻസി. ഒരു എക്സ്റ്റേണൽ ഏജൻസി എന്തായാലും നമുക്ക് എന്ത് വേണം, ഈ ഒരു Clausius സ്റ്റേറ്റ്മെന്റ് പ്രകാരം അല്ലെങ്കിൽ സെക്കൻഡ് ലോ പ്രകാരം നമുക്കൊരു ഇതിന്, അതായത് ഹീറ്റിന് ഒരിക്കലും ലോവർ ടെമ്പറേച്ചറിൽ നിന്ന് ഹയർ ടെമ്പറേച്ചറിലേക്ക് കൊണ്ടുവരാൻ കഴിയില്ല. ദാറ്റ് ഈസ് സേസ് ഇൻ Clausius statement. Okay, these two statements are second law statements. From the second law, the we know heat pump, refrigerator, it is here working on the basis of second law. Then on the basis of first law, we can get two words or two properties that are enthalpy and internal energy. Internal energy. Okay, this is all about laws of thermodynamics. Simply three laws: zeroth law, first law, and second law. Second law contains two statements, or Kelvin blank statement and Clausius statement. Okay, thank you.